My name is Sive. I'm your host for today. And this session is called SDG 17 Sustainable Lessons from Living on Mars. Mars.
Yes, that'd be great.
Apologies.
Thanks, Maya.
So,
yes, sure. But just close your book.
apologies, just muting people. I work for ECO-UNESCO. Who are we, first of all? We're a youth organisation founded in 1986 by a group of young people, and our aim is to empower the young people who are involved with us to help protect our environment. ECO-UNESCO is proud to be one of UNESCO's affiliated clubs and a Sustainable Development Goals ambassador. We're a youth organisation and we focus on environmental education. We're a registered charity and an NGO, and we work with young people all over Ireland. So, before we hop into today's session, I'd like to ask everybody if they could please send into the chat the name of their school and the number of students attending that are currently in your classroom. That would be very helpful for our funding because all these events that we run are free, and so we rely on your guys' attendance and feedback to help us get all the funding we need to run our sessions for free. So, thanks so much. I can see some coming in already. I'll take note of everybody. Today's session, like I said, I have the wrong title up there. My apologies. That was this morning's session. Today's session is called Sustainable Lessons from Life on Mars. And we're going to be hearing a bit from Niamh Shaw. Niamh recalls her experience from living on Mars, kind of, for 15 days, and how it made her appreciate Earth and all of its resources. So without further ado, I'm going to hand over to Niamh.
Thank you, Sai. Thank you very much. I'm just going to play my slides. Hi, everyone. I love giving talks. Happy SDG week, and I'm delighted that you're joining us. And thanks, ECO-UNESCO, for the opportunity to talk to you today. So yeah, I'm Niamh. I love all things space. This is me. This is me standing on the top of one of the amazing ridges when I lived as if I was on Mars for 15 days, living with a spacesuit every time I went outside. And the most important thing I took away from it was how much I loved living on planet Earth. And I didn't think that that was going to happen when it all started. So I want to tell you that story, and I wanted to connect back to how we can be better citizens of Earth and what I learned from living as if I was in space for 15 days. So for those of you who don't know me, I love talking about science. I'm obsessed with space, and I love talking to people like yourself, going on television kind of news reports and on the radio, and I write about space and science, and I give talks. I was on the Late Late. I give talks. I talk for Space Week that's coming up and Science Week. And so everything is about kind of helping us think about our place in space and how it helps us take better care of our planet. So this is a picture of me as if I'm standing on the moon. That's not true. I'm not actually on the moon, but I'm at the European Space Agency. And if I could snap my fingers, that's where I'd like to be. And that's a dream I've had from a really young age, from sort of around the age of some of you. Obviously, your haircuts are much better than mine. My mum used to cut my hair, clearly blindfolded and with a spoon. But when I was around about 9 or 10, I saw this for the very first time. This is a picture that's very old. It's older than all of you. It's even older than me. And it was shared with the world in 1968. And it was the Christmas before we finally saw 2 humans land on the moon. They were 2 gentlemen called Neil Armstrong and Buzz Aldrin from America. And they were involved in making this happen because lots of other people and astronauts went ahead to make sure that everything worked properly. And one of those missions was this mission that happened to be going around the moon on Christmas Eve. And they saw this and they were like, what? And they took a picture and they shared it with the world, and the whole world went, what? Because nobody had seen a picture of planet Earth like that before. Because nobody had been outside of Earth for long enough to take a picture like that. But the people that went to the moon, they saw it. And everything kind of started from there. All of the organizations that we now have that are promoting how to be better and more careful with our planet, all started from that picture back in 1968. And just there on Friday, Look at this picture. It's amazing. So this picture was also taken of Earth, but it was only taken about 2 weeks ago when a mission that's on its way to Jupiter had to go around Earth to kind of get a bit of speed behind it. And when it was sort of far away, it took this picture. And you'll see on the left, if your rooms are dark enough, I don't know if you might be able to see it on your wall, but there's a moon just on the left as well, very dark. It's like a little kind of a hump. Now, that is a selfie of you and me and everyone you know, and your dogs and your cats and all your pets are in that picture, except for the 19 astronauts that were orbiting Earth that day that picture was taken. But other than that, 8 billion people are in that photograph. Isn't that amazing? That's what I love about space. It makes you look at Earth differently. And that's kind of what happened to me when I went on this crazy mission. So let's just review where we are in relation to the sun. So I'm sure you've all seen this. This is a picture of our planets that orbit the sun, our solar system. Now they're much further apart than that, but we have them all clumped together. And I'm showing you this because I want you to see where Earth is in relation to all the other planets in our solar system. So I'm going to call them out as from the planet that's closest to the sun, and then as we move outwards. So first you have Mercury, and then you have Venus, and then there's us, and you can see our moon, and that's as far as we humans have ever traveled. We have lots of science experiments that have headed to Venus and headed to Mercury, and have also headed to the next planet beside us, which is Mars, which I'm going to talk about extensively in a minute. So we have rovers on Mars, and so they're machines that have lots of experiments on board that have cameras and lots of experiments to measure things and figure out what Mars is like. And then the next planet, which is the biggest planet in our solar system, Jupiter, the mission that took the picture of us a few weeks ago, it's heading there. It's called JUICE. JUICE is the name of the mission. And there's another one heading in a couple of weeks called Europa Clipper, and that'll be launching in October. And then the next planet is Saturn. That's my favorite because I love the rings of Saturn. And so we've had missions to look at Saturn, but we've never had any missions to look at the next two, which is Uranus and Neptune. And that's because they're so far away. Just in terms of distance, a mission headed off to look and take pictures of Jupiter and Saturn for the very first time in 1978. And it took 10 years to get to Jupiter, and another 2 years to get to Saturn, and another 15 years to get to Neptune. And it's still heading out into interstellar space at the moment. It's called Voyager, if you want to look it up. So that's where we are. So why is everybody interested in Mars? Well, if you look at Mars, it's sort of the same size as Earth. It's a little bit smaller than Earth, but when all these rovers and all these different experiments have been orbiting Mars, what they've noticed is that there's a lot of things that look the same as the land on Earth. So they have sections where they can see that there's a buildup of kind of different types of colored clay that show that a river used to flow. And similarly, there's these dry beds or basins that show that water used to be there. And so they now know that there was a time when rivers flowed on Mars and when we had seas and when they had a thicker atmosphere. But something happened on Mars. And that's the big mystery. And that's why so many people are interested in returning to Mars. And there is a hope that one day we would have astronauts to go to Mars to figure out exactly what happened on a human mission. But we have a lot of work to do to get there. We can talk about it later in questions. So what did I do? How did I get to go to Mars? I didn't really go to Mars, but I went to a place on Earth that is used to pretend it's Mars for scientists who are trying to figure out what kind of experiments we need to send to Mars. And they're called analogs, or they're called simulated Mars missions. So I participated in a simulated Mars mission in 2017. I don't know what age you were in 2017, but it was 7 years ago. Some of you probably were just very young. And this is where we went. This is in a part of America in a state called Utah, and hundreds of kilometers of Utah have nothing on it because it's desert and it's very remote and the landscape is stunning. And more importantly, they keep finding dinosaur bones here. So this part of the world had a lot of dinosaur activity in it. And it has soil and rocks that are very similar to the soil and rocks that they know are on Mars. So if you look at that there, it's red, which is similar to Mars, is that there's a lot of iron present in it. So if any of you have old gates or anything that you leave outside that has iron in it, iron is a metal, it goes rusty and that rust is red. So there is a lot of iron in these soils and these rocks here where I went to in Utah, but also on Mars. And that's why it has that distinctive red look. So I joined a group of scientists and geologists. I'll tell you about them in a second. And we all lived here. You see that building on the left-hand side of the screen? It's got like 2 or 3 buildings and then a kind of a tunnel. That's called the Mars Desert Research Station. And I lived there for just 15 days and it changed my whole perception of planet Earth. And I went with these people and they're from all over the world. I had geologists. So geologists are scientists that like to understand the landscape of, like, so they look at a field, we see grass, we see cows, and they go, clearly there was a volcano, that this happened in this section, and they're able to tell the story by looking at different rocks and formations. So obviously geologists are going to be very interested in Mars if they're trying to figure out what happened on Mars. I also spent time with astrobiologists. So biologists are interested in living things, people like me, your cat, your dog, plants, animals. Biologists, it's biology. Astrobiologists are interested in those creatures that can survive in extreme environments. So on Earth, they would be places like deserts, volcanoes, underwater, extremely cold places, extremely warm places, extremely windy places, extremely wet places. There is life in all of those places. There's also life right across our universe. So astrobiologists are very excited about, seeing what's on a comet or on an asteroid, but they're also very interested about life on Mars. So that's why we had astrobiologists joining us. And I was there in my capacity as a talker, as somebody who likes to give talks and write about things and share information and talk about like what it feels like to go to these places. So my job was to take loads and loads and loads of videos and listen to these scientists and help them out with their projects, because I am an engineer and a scientist as well. And we spent 15 days together. So what's it like to live on a place that isn't Mars, but we're pretending to be on Mars? So firstly, the difference, the fundamental difference between Mars and Earth is there's 2 things. One is, well, there's 3 things. One is if you were to take a breath on Mars. So I'm going to take a breath in now. You can join me. So I'm going to breathe in and then I'm going to breathe out. Could you do that on Mars? The answer is no. And the reason is that we breathe in oxygen, which is everywhere around us. But when we breathe out our waste product, which is carbon dioxide. And the atmosphere of Mars is full of the stuff that we breathe out, but it has none of the stuff that we breathe in. So if you were to walk outside on Mars without any protection, it would be like holding your breath underwater. Now, I don't know about you, but I can only hold my breath underwater for a couple of seconds. So you need something to support you. So you need a spacesuit. So that's why in this picture, we are wearing our flight suits, which is what I have on now. I'm going to stand up. That's what I'm wearing here. So I kept it and I'm wearing it now. I don't know if you can see it. So I'm wearing it now. I've got a few extra badges on it, but this is what we wore when we would go outside, because this is like our spacesuit. It's not really a spacesuit because it's perfectly safe to walk outside on Earth. But when you're pretending to live on Mars, you have to put a suit on because you're trying to imagine what that life is like. And it's really awkward and difficult and time consuming to put all the gear on to keep you safe if you didn't have oxygen on, like on Mars. So we had a helmet and we had a rucksack and or like a backpack, and the backpack had a fan, and the idea was it was blowing in fresh air into our helmets. Now we didn't need it to be oxygen because there's oxygen everywhere, but just the whole sequence of putting that on that's what you would do if you were living on Mars, right? That's the first thing. Second thing is there a Tesco on Mars? No. Is there a house on Mars? No. Is there streets on Mars? No. Are there cats? Are there dogs? Are there trees? Are there birds? Are there buildings? Are there offices? Are there shops? Nothing. There's nothing on Mars. So what that means is that you have to bring in everything you need to live in this habitat, because that's what you'd have to do on Mars, right? So there's no shops there either. In the desert, there's nothing. So it is kind of like Mars. There was no streets. There was nothing. There was no cats, dogs. There was nothing there. There was no shops. So we had to bring in our own ration of food, and we also had to bring in our own ration of water, because there's no taps in these places. Like, we take for granted that you have a flushing toilet in your house and that you have taps and sinks, and the same in your schools. You don't have any of that when you go to the desert, and you certainly don't have it on Mars. So they were kind of the three main things that made it very different on Mars. The third thing, and you can't actually pretend this on Earth because there's nothing that you can do about it, is that there's gravity on Earth, and it's a certain amount for Earth, but it's much less on Mars. So we couldn't simulate that. So we had to just assume that everything is much lighter on Mars, and that's all we could do about that. We had a load of experiments to run because we had to apply to go here. It's a scientific experiment that we ran for 15 days. And so this was what it was like to live there. So I'm going to see, I can't play these videos, so I'm just going to come out here and I'm going to play the videos just from my slideshow. So this was what it was like. This was our house, and it's called a habitat. Anything that you live in that's not on Earth is called a habitat. And so we had a 2-story habitat, that round building. And every time we would go outside, we'd have to wear our spacesuits, and we would have to go through an airlock, which is a double door system. Because if you didn't do that, if you were on Mars, all the oxygen that you would have created to live in your habitat would just go out the door. If you just had an ordinary door, you need 2 doors. So you open one and close it behind you, and then you open the second one and you close that behind you. We had a greenhouse, which was called a green hab, to grow vegetables. And then we had a tunnel to go to the science lab. Now, the tunnel was the only place when we were on the simulation that we didn't have to wear a suit, because the tunnel was like, if it was on Mars, it would be an underground tunnel, so you wouldn't have to suit up. So that's what we did. And then all those different vehicles, the car we didn't use, we used that to get there, which took 2.5 days. And the vehicles then we used to go around and take samples. And you'll see video of that in a second. So that was that. So now, what was it like to live there? Well, let me show you. So this was the downstairs. That pink light is an experiment where we were trying to see if we could get plants to germinate, for the seed to grow a root, which is what germination is, under a different color light that's as close to visible light as you can get, because that's what happened on Mars. This is where we would suit up. So you can see our spacesuits there, our helmets and our backpacks, and then our flight suits, which is what I've on me now. This was the airlock, the double door system that I told you about. So you would suit up in there. And it would take about 40 minutes for the whole thing to put on from start to finish. I've got a video about that in a second, you'll see. So that's the experiment. And then, so all downstairs was the toilet and where we ran our experiments. And upstairs was kind of like our living quarters, very basic. This was a very old facility, about 20 years old, nothing worked. And the only private space we had were our own little bedrooms. And you'll see my bedroom in a second. We had a kitchen, which you wouldn't have on Mars. So that was a luxury. And I'll show you what we eat. And I'll show you in a second how we got water into the facility. So we had a very limited ration of water. So this was the only private space that I had. This is where I would go to sleep at night. Not very nice. I had to bring in my own sleeping bag, my own pillow, all this equipment. So I had no room for clothes. So I only could wear the same 2 pairs of trousers and the same 4 tops and whatever underwear I had. That was it. You couldn't wash clothes because you couldn't afford to use that water. Water was an absolute high value thing that we absolutely had to preserve and keep for as long as possible, because we only had a very short supply, and if we ran out, we had to end the experiment, and we didn't want to do that. This is what we ate. We had these cans of dried food. This is egg. Yeah, Michaela's face says it all. Pretty disgusting. So what you would do if you wanted to make scrambled eggs, you would take some spoonfuls of that, you would add some water, you'd put it on the frying pan and you'd eat it. It wasn't very nice. Everything was extremely salty. I didn't like it. But we had dried egg, we had dried sausage, dried butter, dried orange juice, dried milk, dried potato, everything. You had to add water to it. So we used water for everything. And so water was really, really valuable. So we only flushed the toilet for number 2s, not number 1s. There was these like big plastic kind of tanks that were full of water. And then there was a pump that went into the house. And when you turned on a tap, the pump would literally go, suck some water, push it down the pipe, suck some water, push it down the pipe. And when it would do that, it would make this sucky sound that was like, it would make a kind of a honk, like a goose or something. So you would know how many sucks of the water would happen, because every time it would suck water, it would go, So you would know when you turn on the tap for, say, brushing my teeth, I got to know very quickly that just 2 honks would put enough water on my toothbrush. Then I would turn it off, I would brush my teeth, and then to rinse it, it might take 3 or 4 honks. So it would go, and then I would do my toothbrush, and then I turn the tap on, it would go, like that. Washing my hand, 5 honks. Flushing the toilet, 20 to 30 honks. That used a lot of water. To wash up, what we would do is we would use the water that we would use sometimes to boil some vegetables and stuff, and keep that to wash our dishes. So nothing was very clean there. It was pretty filthy. We didn't shower the whole time we were there. Yes, we were smelly, but we only realized how smelly we were after the experiment was over. And then the really kind of interesting part of the whole thing, I think, was when you would put the suit on. So up until now, it's kind of like a caravan holiday where you're not allowed to go outside and the food is awful and you only had limited water. But what really made it feel like you were on Mars when you would put this thing on, and this is, again, this is fake, this isn't even real, but it would make you feel very confined because you had gloves on, you had boots on, you had a walkie-talkie. So the only way people could hear you was through the radio. And you had this very heavy backpack on and this very heavy helmet. And so you had to really be careful how you walked, because if you fell, you would hurt yourself. And previous missions, they have fallen. And because you're so far away, they have to be airlifted by a helicopter. So you didn't want that to happen. So you had to go in groups of at least 2 when you went outside on a spacewalk or an EVA. And you were going out to get samples for the geologists and the astrobiologists. So you weren't just like driving around, you were going over rocks and climbing all these different peaks. And I'm not great with heights, you know. So this is the flat surface. This is the only flat area of where we lived. So that was the only place where I could kind of hold my camera where I wasn't afraid it was going to kind of get damaged. And so you're wearing this really awkward suit that took you 40 minutes to put on, and you're going around with your radio, and you have to keep you can't go too fast in these bikes, because your job is to make sure the person behind you is safe. And so that's all you could do. And so you see me here, I've got the same flight suit on that I have on here, and I have my space suit on, and I have the Irish flag. And you see when I walk, I'm really careful how I walk, because you trip all the time. And so tripping here is one thing, like you might kind of get a tear in your suit, that's fine. If you did that on Mars, you'd have to get back to your research station as quick as possible, because you'd run out of oxygen, and you would be exposed to, you'd also be exposed to an awful lot of radiation as well as that. So so let me just go back to my main slide. So it was an incredible experience. And within about 4 or 5 days, I felt as if I was on Mars. I didn't miss anything. There was one night, one of the geologists was cleaning his room, and he brought out money. He brought out like dollars, because it was in America. And I was like, gosh, we don't need money here. And I really liked that we didn't need money, actually, because it was like, it's so easy when you don't have to keep going to the shop, when you have all your food there. But we were paranoid about our water. Like, it got quite scary at times. And that's why we didn't shower. Our toilet blocked the first few days, and we wasted a lot of water trying to fix that. And we were very worried. And so as the days went on, we used water less and less and less. And when the experiment was over, it was great that it was over, because it was quite hard. You know, like you've no friends, you can't talk to anyone, you don't have internet, you could only use the internet to do your reports. Your day would start at 7 a.m. and it would finish at 1 a.m. So you were exhausted. It was very hard to sleep there, because it was like sleeping in your garage with the freezer on and the washing machine going full, where there was all these machines going on, and it was cold. And so they used this hot air to keep you warm. and I was sleeping on that top part of that box, and warm air rises. So during the night, you'd be like, "Ah," like all this hot air would be blowing into your face. You'd be like, "Ah." It was so uncomfortable. And I was really dehydrated when I was there. But I can't just go up to the tap and go, oh, cheers, and take a drink of water like I can now, because we're watching our water. So we finish the trip or the mission, and we drive back to the nearest town, which is this one street town called Hanksville. It took us about an hour to get there. And we decide that we're going to spend the day in a national park, because Utah, where we were, is full of national parks where you can see dinosaur bones and everything. It's an amazing place. And so we went to this cafe. I mean, it was dirty, but compared to where we'd been, it was amazing. And I got coffee and pancakes and bacon, and it was delicious. And we've got the map out, and we said, right, we're going to go here. We went to a place called Canyonlands, if you're interested in looking it up on the map. And you can see the Mars Desert Research Station if you Google it as well on your Google Maps. And you'll see that it's in the middle of nowhere. And I said, right, I'm just going to go to the bathroom. Won't be a second. So we go to this huge bathroom where it has different cubicles. And I go to the bathroom, and I'm just going to the toilet, number one. I'm not doing number two. And I get up, and I was just going to walk out the door. And then I realized, oh, wait, I can't do that. I'm back on Earth. And so I flush it. And I'll never forget the fright that I got, because I was convinced that I had broken the cistern or something, because so much water came out in comparison to the toilet on the Mars Desert Research Station. And I was like, ah, because I had seen that it took 1/10 of that water to flush away poo. So why was there so much water being used just to flush away my 100 mils or so of urine? And then I went to the tap to wash my hands. I'd been used to 5 honks to wash my hands. I put my hand, and like all this water comes out. I'm like, ah, stop. Because I was like, oh, because I'd been used to turning it off while I put suds in my hand and then putting it back on when I rinsed it again. So wasteful. Say goodbye to everybody, and I come back to Earth, or come back to Ireland, and I go into my apartment, and it's like, oh my gosh, this is huge. And I just looked around at all the stuff that I had. And I didn't miss any of it. Not even my books. I love books. And I was like, why am I hanging on to all this stuff? I don't need this stuff. I need to give this to people who use it, because I've used it. And so I started giving away everything. And for 4 years, I lived with no personal possessions. I had some clothes, and that was it. I gave away loads of clothes. I gave away all of my towels, all of my duvet sets, all of my cushions, my television, my microwave. I gave everything away. And I lived for 4 years without a car, because I wanted to see what it feels like when you live with a house and a street, with cats and birds and shops and everything. Can you live more simply? And the answer is yes, you can. It's difficult in Ireland to get around without a car. That's the only thing. I had to hire some go-cars from time to time. So, actions. What did I learn that you can think about for yourself? So firstly, water. Water. We underestimate how lucky we are that the houses we live in, we just turn a tap and there's some water. There's lots of places on Earth that don't have that, and they have to walk miles for water. And I got an appreciation of that when I was on the Mars Desert Research Station. But there's nothing stopping us saving our water in our homes. Just because we have it on tap doesn't mean you have to use it that way. So really think about how you use water. Think about when you go to brush your teeth. Think about just wetting your toothbrush, turning off the tap while you brush your teeth, and just turn it on to rinse your toothbrush. You don't need it on the whole time you're washing your teeth. And also when you're washing your hands, think about that. Your stuff. Really think about your stuff. Is there anything in your room that you haven't used for a while? Somebody would find use for it. So give it back. Give it back. I buy all my clothes now in secondhand stores, really nice ones too. Some clothes haven't even been worn because I think we can reuse things way more than we have been doing. And around schools as well, are there things that you can reuse that you can share with other classes? Really think about the lights that you turn on and off. Think about ways to just bring that down. And lastly, Are there cheaper ways to get around? Do you have to use a vehicle? Can you use public transport? Can you cycle? Can you walk? Can you run? So these are some of the things I want you to think about from my experience. And then I want you to look back at this and realize that that is the biggest selfie that's ever been taken. So I'm in that picture and you're in that picture. And we're blessed that on our planet, we have oxygen, we have water, we have food, and we have gravity. And there is nowhere in space that has all of those things in abundance the way they have here. And so it's our responsibility to take care of our planet, because even though maybe in your lifetime, you're going to see humans walk on Mars, but I'll tell you, they will not have the quality of life that you have, because Mars is a very, very harsh place. Everywhere in space is a really harsh place. So the only place that's built for humans is Earth. And so we have to think about that and ask ourselves, what can we do to create a healthier and cleaner Earth where we can share our resources more fairly? So I'll leave it there and I'll see if you have any questions.
Thanks so much, Niamh. That was a really great talk. Yeah, let's open the floor up to questions. So if you have a question, please send it into the chat, or maybe if someone wants to ask, raise your hand and you can turn on your microphone and ask your questions. Let's see what we have.
Yeah.
Oh, we have a hand up from Marino School in Bray. Would you
Yeah.
like to ask a question?
How long has the season been?
How long has what been?
The season been?
The season.
Yeah.
I think Niamh, Grace means if there's seasons on Mars.
Oh, brilliant. Yeah, I guess there is Grace, but I this is where we don't really know. We're only, the current rover Perseverance has like it has a weather sensor on board for those very things. We know that Mars is very windy. We know that it's very cold, but we don't know things like seasons because there's no life there. So you, like, if there was trees, you could tell, oh, it must be winter because the leaves are falling off. There's nothing that's affected by the seasons on Mars because nothing is alive there. But the really interesting thing, Grace, about your question, and it's a brilliant question, is, you know, the way we have seasons, right? So we have spring, summer, autumn, and winter. And that's because we go around the sun once a year. And sometimes we're further from the sun than sometimes we're further than the sun than the southern hemisphere, and when it's winter in Ireland, it's summer in Australia, and vice versa. And we don't know what the impact is of that on Mars. We know that there's ice in the south pole of Mars. There's water kind of held there. And we also know that it takes 2 years for Mars to go around the sun, a little over 2 years, where it takes us a year because Mars is slightly further out. So we know that it's colder, but sometimes it's further away from the sun than other times of the year. So that's a great, great question, and I can't answer it for you.
Thank you, Niamh.
Thanks so much. Let's hear from Emily Michalik's classroom. We have 2 hands up over there. Do you want to speak, Emily? Oh, I think you're muted there. If you just turn on your microphone, we'll hear you there. Oh, I think we're having a sound issue. Why don't you type your questions into the chat and we'll read them out as well. Let's have a question from Maggie's 6th class. We have lots of hands up there as well.
Could an ice age stop global warming?
It's a really good question.
He Googled it earlier and we couldn't find the answer.
Well, you know, I think that's a really smart question. And I don't think anybody has the answer because we haven't had an ice age in a long time. We do know, and this is sort of a segue, and then I'll get back to it, but we know amazingly they managed to cut a core of ice in Antarctica that went all the way down. And it has 800,000 years of information, because every year when it snows, there's another layer that goes on to the ice, and they're able to determine how much carbon dioxide is in the ice. So they know, and they're able to measure, they're able to, by that, they're able to tell what the climate was like at the time. And so they charted it, and they saw like there's a peak where the planet kind of warms up, and then during an ice age, so every 100,000 years or so, there's an ice age. So you get these peaks, you have about 8 peaks. And then suddenly around about the late 1800s, it starts to go up, and it keeps going up, and it goes way higher than any level before of the ice age. So some people have said, oh, you know, the planet's warmed up before, and then the ice age has kind of cooled it down. Yes, but what we've added to our atmosphere is exponentially way more than the natural cycle of our planet. So yes, I agree. Why I think the ice age might actually help the planet is that if there were an ice age, there'd be less movement from humans. And so we wouldn't be able to move around and do the things that we're doing. And so for that reason, maybe there would be a reduction in the amount of carbon dioxide that would build up. So over a couple of 10,000 years or so, it would naturally go down because we wouldn't be able to do what we normally do. But it didn't solve, you know, it's part of a natural cycle, the amount of carbon that we naturally have. But the addition that humans have put in, we haven't had an ice age yet to measure that, but fantastic question.
There's just one other quick one here, I think, from the class. Ade?
Are there any signs of oxygen on Mars?
There's no oxygen on Mars, no. So the atmosphere is carbon dioxide, and a really thin atmosphere as well. So it would sort of feel like, even if we could breathe carbon dioxide, it would sort of feel like, you know, the way climbers go to Mount Everest and they have to wear oxygen. That's because the atmosphere gets very thin the further up, the higher up you go. So the thinness of the atmosphere would be very similar to, you know, living in the very high hills on Earth. But there is no oxygen on Mars. Now, a really interesting experiment on the Perseverance rover is that, you know, how do they get oxygen to the International Space Station, for instance, right? Because there's no oxygen up there either. So they use a chemical reaction to get the carbon dioxide. They run a chemical reaction through it, and then they can take, it comes out as water and oxygen. And so because they know that they can do it on the International Space Station, on the Perseverance rover, they put a little experiment on board where they took some carbon dioxide from the atmosphere, they ran their chemical reaction, and sure enough, oxygen was formed. So if you were to live on Mars, we would have to have some sort of chemical process to create oxygen. Other things that have been suggested, and I don't know if this is a good idea, is this notion of terraforming. So terraforming is where you take a whole planet and you change its natural ecosystem to suit the needs of a parasite, which in this case would be humans. So there's talk of people, you know, putting a massive kind of, you know, sending an asteroid or something to Mars to open it up and to create like a chain reaction to change the atmosphere, and so that oxygen would be rapidly formed over a couple of 1,000 years or so. And that's another way of putting oxygen into the Mars atmosphere. But naturally, no, there is no oxygen on Mars.
Thanks so much, Niamh. We're running out of time, so I'm just going to do my little piece before the end. Maybe you can answer some of the questions as they're in the chat. I see some great ones in there. I'll just say the last little piece and then we can wrap up, and maybe we can have more time for questions if Niamh has a bit of time to spare. So yeah. Let me just put my screen on again.
I love the questions in the chat, actually. They're brilliant.
Yeah, there's some great ones in there. Unfortunately, we don't have time to get to all of them. But yeah, Niamh will get to as many as she can. So on my behalf anyway, I just want to say thank you so much everyone for attending and all your excellent questions. If you could, please, would you be able to give us some feedback? This really helps us to run free events because it means we can get funding from lots of different people. I'll also send, if you can't use the QR code, I'll send a link into the chat as well, so you can use that instead, and you'll be able to access it after as well. So,
all right,
let me just grab it here. So if you could please fill out that form when you get the time. I'd also like to invite you all to get involved with us at ECO-UNESCO. We run a couple of different programs. So for you guys in primary schools, we'd be mostly promoting our Young Environmentalist Award. So maybe today's session inspired you to do your own project. We have the Young Environmentalist Award, which is an all-Ireland programme where young people take action in their local areas and communities. And it's free to enter, and all the details are on our website. So if you're interested in doing your own action project, you can start up there on our Young Environmentalist Awards. And we also run workshops as well. So that's where someone like me, for example, will come to your school and deliver workshops on lots of different sustainable topics like fast fashion, ecology, our oceans, and lots of other ones as well. We also run youth groups. So if you're based in the Dublin area, in Galway, around Galway City, if you're based around Drogheda or Maynooth, we run loads of youth clubs in those areas as well. So if you're interested in learning more about sustainable development in general and making some new friends, you can join our youth groups as well. So Eco Week is running all this week. We have lots of different sessions that you can attend. You can see them all here. This one has been Sustainable Lessons from Living on Mars, and we have lots more to come as well. So biodiversity, all about our oceans, about young people who are taking action, and lots of other stuff too. So it's really, really exciting. And there's still time to sign up for all of these events. So please do get involved. So with that, I'd like to say thank you to everybody. You've been really great. If you haven't done so already, please send in the name of your school and the amount of students that are attending. Like I said before, it's really good for our funding and stuff like that. So if you could please, if you haven't done so already, I think nearly everyone has, please send in your details. But other than that, I think we'll leave the questions back to Niamh again. I think some people are really looking to answer their questions. So if you want to stay and listen to Niamh's answers, you can, or feel free to leave as well. I know some people are finishing up school at this time as well. So thanks, everybody.
Thank you. Right. Okay. So I'm going to go through them. So would you like to go to Mars? Yes. But the really interesting thing about Mars, because Mars takes longer to go around the sun than Earth, there is only once every 2 years where Mars and Earth are close enough for it to be 7 months to get to Mars. So what would happen is it would take me 7 months to get to Mars, and then I'd have to wait 2 years for the two planets to get close enough again. So you can only ever go to Mars once every 2 years. So it would be a big commitment, but yeah, absolutely, I'd love to go. How hot was it in Utah? It gets really hot. Oh my gosh. I would say I was there during the summer again. So it got to about, I was in the desert at one stage and it was nearly 50 degrees centigrade, but that's climate change. That's climate change as well. Did I find any dinosaur bones there? No. And if you find one, you're not allowed to touch it. There's all this protocol because we were out rambling in lots of different areas. And if you find one, it's illegal to touch it. You have to immediately call, and there's a number that you call, and then they take it from there. But I saw, oh my gosh, in Utah, they had this museum, all of bones that they had discovered in this area. And oh my gosh, like they had like about, they had about 30 different types of dinosaurs, and they were huge, and they were full sets of their skeletons. So there are so many dinosaurs in Utah. I'm not sure why. Do I miss living on the Mars project? Yes, it was kind of perfect because it was just like we got into a daily routine. I really liked the people that I was living with. Now I miss my family, and after a while you do start to go a bit stir crazy, but I think as long as you have a team of people that you get on with, you can do pretty much anything. And actually, you know, talking about space, that's what they really look for when they're looking for people to join them in different missions. Astronauts of the future is people that are team players and people that take care of each other. So sharing and caring are actually two of the really important parts. So you might have all the right qualifications, but they will do lots of psychology tests on you. And the most important thing is, do you think about the needs of your crew, which is your friends? And if you put those needs, sometimes, you know, for the good of the team, that's really what they're looking for. How did iron form on Mars? Well, you'd have to ask a geologist that. I mean, some rocks naturally have iron in them, and the same here on Earth. We have iron containing rocks here, which is why some of the rocks are red. So if you come across any rocks that are red, more than likely there's iron in those rocks. And all of that formed, you know, from, you know, the core of our planet is magma. And so that's like a ball of kind of melting iron and all different elements. And when there's a volcano, that stuff gets spewed out and it gives all sorts of different rock formations. And this is the foundation of what geology is like some are formed from the volcano, some are formed from sediment from the rivers and all this stuff compacting, and some of them transform and become what's known as igneous rocks. So they want to know what changed from Mars. That's the nobody knows. Nobody knows. Nobody knows. That's why we need to know. There are some theories that the magnetic field changed. There are some theories that something happened in the atmosphere. And so because the atmosphere basically got ripped away, that everything just dried up. Nobody knows. That's why everybody's so interested in Mars. How long did I stay there for? Just 15 days. You wouldn't think it. It's incredible because the experience still stays with me. Like it's defined the whole way I talk about space, because I think the really important thing about space is how we think about ourselves and how we can take care of our planet. And that all happened because of that mission. Were there any signs of animal life where I was? I saw nothing, but I'm sure there was like gophers and little kind of rodents and stuff. You'd see little holes burrowed from time to time, but I saw nothing. No, I saw nothing. You'd see kind of tumbleweed and you'd see kind of twigs and stuff, but very little life there because it's so dry. How much radiation is there on Mars? Great question. A lot. Our atmosphere protects us from the radiation that's out there in space. So, for instance, last week we saw an astronaut who paid himself to go up and do a spacewalk from his capsule, and he was much further up, higher up away from Earth than the astronauts on the International Space Station. And so he went through what's known as the Van Allen belt, or the Van Allen belt, and that's a belt of radiation. And anything beyond that, you're going to get pinged from all sorts of radiation coming from the sun and just radiation that's out in the universe. What protects us from that is our magnetic field. So Earth has a magnetic field, which is why we have north and south, which is why magnets work. You know, I have a magnet here. That's why magnets work. We have a magnetic field here on our planet in the same way. And we have our atmosphere. And our atmosphere keeps a lot of the cosmic radiation away, as does our magnetic field. So Mars, its atmosphere is much thinner and its magnetic field is hardly anything at all. It's completely changed. So that's why. Could water be transported to Mars? Well, it's very heavy. It's very heavy. So trying to take off with a lot of water would be very difficult, but it's a really good question. You would have to have like, I don't know how they do it. So how do you do it? I don't know. Like you could, like water, also getting people to Mars, they're going to be exposed to a lot of radiation. So some people think if you put water is a really good protector or insulator from radiation. So some people think, well, maybe you could build the spacecraft and put water around it and then they could use water afterwards. It's probably safer to use the same chemical reaction that gets oxygen out of carbon dioxide, that you can use that to create water as well. But we found water on Mars now, not only in some of the rocks, it's also got water attached to rocks, but you've also got lots of water in the south pole of Mars as well. We have to go, that's fine. And are there any other planets where people can live? Not yet, no. We have found that there are planets in most stars that you see up in the night sky. There's usually planets orbiting stars. We know that there are planets in the same position to Earth that are just near enough to the sun that they can get heat. They're not too near that their atmosphere is going to, you know, disappear like with Mercury, and it's not too far away that it's going to be too cold. We know that there is life, like small microscopic bacteria and stuff on comets and on asteroids. We found nothing like Earth. And also, we need a certain gravity as well for us to be able to live the way we do. And we don't have that. How long has the storm been going on in Jupiter? Great question. Hundreds of years. And do you know that you could fill about 8 Earths into the size of that storm? That's how big that actual storm is. It's incredible. Were we allowed to use toilet roll? We couldn't flush toilet roll, and this was pretty disgusting. There was a bin, and actually they do this in some, I have spent time in other countries and you have to do this as well. There was a bin beside the toilet. So whatever toilet roll whatever toilet paper you use, yeah, some can be pretty disgusting. You then wrap it in more toilet roll and you would put it in a bin beside the toilet, and then we would burn that once a week. And again, you couldn't do that on Mars because you need oxygen to burn things. So I don't know how you would do that on Mars. So yeah, it's pretty disgusting. How long has space existed? Molly, great question. If I told you 12 billion years, would you believe me? Because that's how long space has been around. Our planet has been around for 4 billion years. Our sun has been around for 4 billion years. But actually, the universe that we know it now started 12.1 billion years ago, as far as we know, we think. Has any robot ever dug through the surface of Mars? Yes, it has. So the Perseverance rover at the moment is doing this incredible thing. It's going, it's burrowing down, and it's got these kind of things that look like cups, and it's putting what they're finding, these rocks, in the cup, and they're logging where they're leaving them. And so there's a return mission called a sample return mission, which they're planning on doing, where another rover comes along, picks them up, and flies them back to Earth, because we want to be able to get our hands on those rocks in order to really understand what's happening. There's only so many experiments that we can do that allow us, look at things remotely, like through different kind of pieces of equipment on the Mars rover. But actually bringing them back to Earth would be terrific. And that reminds me, we had an asteroid that we had 2 missions that recently went to 2 different asteroids, and they brought the stuff that they collected back. They basically put it back into an orbit, and it fell back to Earth, and scientists are looking at it right now so that we can actually figure out, with our own equipment and our own labs, what's actually in those asteroids. So that's what we hope with Mars. So in the next 20 years or so, we're hoping that we're going to have those samples back on Earth. And I think that's it. Is there iron on Mars? Yes, that's it. Okay, there are all the questions. So are days shorter in Mars than on Earth? Ever so slightly shorter, by about a half an hour. So if we had astronauts living on Mars, we would have to think of a year is different on Mars and a day is different on Mars. So we'd have to think of a whole other way of measuring time. So that's it. There are all the questions. Sive, I'll hand back to you.
Thanks so much, Niamh. That was absolutely excellent, and thanks so much for staying on longer than we originally planned. But there were so many great questions in the chat. I didn't want to miss any of them.
Yeah.
So I'm aware a lot of you are probably finishing up school now. So if there's no more questions, that's all, then please feel free to leave. I'll answer any of the leftover questions, and I see some people are asking for emails as well. I'll send on all the information later, so don't worry about missing out on anything. I have all of your emails and information from your tickets, so don't worry about any of that. So thank you all so much, and I hope to see you at our next talk for Eco Week. So bye, everybody.